Namaskar and a very warm welcome to NCERT's live interactive program. I am Neha Tripathi. You are watching us on SWAYAM Prabha's channel Kishore Manch, and you can also watch us on our official YouTube channel NCERT Official. Today we are going to learn about sets. As in our previous session, we already learned about the basics of the concept of sets, its meaning with examples. So today we are going to discuss more aspects of the topic. To help us understand this in detail, we have with us Dr. Ajit Thomas. He's joining us from Regional Institute of Education, Bhopal. Welcome to the show, Dr. Thomas.
Namaskar.
Before we start our conversation for the day, I would like to inform our viewers that if you have any questions related to this topic, you can call us on our toll-free numbers 1-800-111-265 and 1-800-111-2199. If you are watching us on our official YouTube channel, you can call us. You can send your questions in our comment section. And if you want to mail us, you can mail us your questions, your queries, your suggestions, your feedback on ciet.kishoremanch@gmail.com. So let's begin the session, and we'll take up questions, viewers' questions and queries as well. So keep posting us. So Dr. Thomas, if we can start our session with a quick revision of the previous session and what we are learning today, if you can tell us that as well.
Yes, ma'am. Thank you to welcome me. I want to welcome all the students, and most probably your parents would be there with you, or your teacher that will be there with you. So first of all, I want to suggest that you be ready with your pen and pencil so that you will work along with us and you're going to learn together. So in the last session, we have discussed about set. Set is very fundamental concept in mathematics. That's why it is kept in the chapter 1 of class 11th. So, and because it has relevant in other chapters like relations, functions, integration, differentiation. So set is very fundamental. So in the first session, we have dealt with the basic understanding of set. What is a set? How to represent sets. So today, what we are going to do, certain other aspect of the set. So I will like to share my screen.
Yes, we will learn about the types of sets and other different aspects of set for class 11 students. Please be with us. Yes, sir.
Okay, so this is the definition of set. And you can see in the definition, I have bolded 2 words that is well defined. So it is necessary that while defining a set, it is not merely a collection of objects. It should be well-defined collection of objects. So in the last session, we have dealt a good deal about it. Generally in mathematics, in set we talk about, there are certain notations we use. So you can see in the screen that we are using capital letter N for the set of natural number, capital letter Z for the set of integers, capital letter Q for the set of rational number, capital letter R for the set of real number, then Z plus for set of positive real number, then Q plus for the set of all positive rational numbers, and R plus for set of all positive real numbers. So whenever in a set you find these notation, bold letter N, or you should understand that it is a natural number. It is represent natural number. When you see any bold letter Z, you should understand that set of integer. So these notations are also very important while defining a set. Certain points we have discussed in the last lecture also, that such objects, elements, and members, these are synonym terms. So if you define a set, the elements, so you use these words synonymously. Sets are usually represented by the capital letters A, B, C, D, or any of the letters which is in the English alphabet, and the elements of the sets are represented by the small letters A, B, C, D. So you may use any of the small letter to represent the element of the set. Just for a quick revision, as Madam told, there should be a quick revision. I have there is 2 examples for representation. So in the last session, we have discussed about how to represent a set. So there are 2 ways to represent a set. The first is the roster form or the tabular form. So you can see in the first example, I'm representing the set by the capital letter A. Then I'm using an equals to sign. And all the elements of the sets are included within the braces. So this is how we represent the set in the roster form. And you should know that the elements are separated by commas also. One thing to be noted while representing the set in roster form is that the order is not important. So if I want to write the same set, I could have written like this also. I could have started with 10, then I could have written 9, 8, 7, 6, 5, 4, 3, 2, 1. So while representing a set in roster form, you should understand that the order is not important. So any order, this is one of the orders. So this is one of the two ways. There are other ways also. If you change the order, the set doesn't change. So while representing in the roster form, so this is the way how you represent any set in the roster form. So if I want to represent this in the set builder form, so I'm representing the same. If you want to represent the same set in the set builder form, then I'm going to use the same letter A. Now this A is not that I should use only A. I could have used another letter B also, capital letter B also, as I told in the beginning. To name any set, we use the capital letter A. Then the same equals to, then we're going to use the braces. Then this variable, so you can see a variable over here. So I'm using X over here. Again, this X is not that we could use only X. I could have used any other English alphabet in the small letter English alphabet. I could have used Y, I could have used W. So it is read as for all X. So it is read as for all X. So in this set, so it consists of all X which satisfy certain properties. Now, what are these properties? These properties are given in the form of statements. Now, there can be one statement or they can be more than one statement. So you can see that after X, I'm using a colon. So what does this colon means in set language? This means such that. So how you're going to read? A equals to X such that. Then you can see that there is a statement in mathematics where X lies between 0 and 11. Now, if I would have written only this statement and I've written nothing else after that, then it could have, because I know that there are numbers like 1.5, but there is no number in our roster form, which is in the above example. So I want to convert the above example in the set builder form. So you can see that this statement is not enough. So define the set completely, the above set completely, then what I have to do, I have to bring more statements so that it becomes more clear. So you can see that these are taken from the set of natural numbers. As I've told you, certain letters are reserved for set. So when I'm using capital N over here, this means that this is set of natural number, because as I have earlier told that there are certain letters which has been reserved for set. So and there is one more symbol that is I'm using in the last session also we have discussed that this symbol means belongs to. So if I want to read the entire thing, then how I'm going to read in set builder form, A equals to X such that X lies between 0 and 11 and the X is set taken from the set of natural numbers. So I think so it is clear to you. These are some questions which are for you students. You may take the screenshot while we will moving forward. You can work on it, and if you have any query and if you want to show us or your answer, then you can just tell us so that we can show your answer in this live session.
Yes, Dr. Thomas, our students can take a screenshot of these questions and they can solve them and reply to us on our official YouTube channel, NCERT official, in the comment section. They can also mail us if that they find more comfortable too. And they can call us and tell us your answers as well. Our toll-free numbers are always there on our screen. So we can go ahead with the types of sets now.
Yeah, actually, madam, types of set. Okay, this is the question. I want to just describe this. The student has to write in the set builder form. Okay, we are going to discuss about type of set. Types of set. There are in different categories we define set. Before that, there is something which is analogous to 0, because our students are familiar with 0. So our forefathers, when the number was invented, they might be felt a problem. They might have felt a problem to count the cattle or sheep which or any belongings which they had. Then suppose they have 10 sheep, then there was a representation to represent 10 sheep. Then what happened? There was to represent certain things like this. If I have 5 apples, I can represent it by the letter 5. If I have 4 apples, then I represent it by number 4. But how to represent a number when I doesn't have any apple? So most probably what I'm going to use. So after that, so there was a need to represent a number number which has nothing. Okay, for that we have 0. Similarly in set, if I give you an example, of a set and ask that everybody, students know that there are 12 months in a year, starting from January, February, March, April. If I ask you to make a set, of months having 32 days, so what are you going to do? So you know that a month, if I talk about January, then it has 31 days. If I talk about February, it has 28 or 29 days, depending upon whether it is a leap year or whether it's not a leap year. Or if I talk about March, then it will have 31 days. But if I ask you to make a set of months which have 32 days, then probably I have to represent. Again, this is a set, but how to represent it? If a person comes like that, there is no month with 32 days, so he may represent like a set and he may represent a 0 inside that set. But this has a problem, because when I say that a month, number of months with 32 days, then there is no month with 32 days. But if I give somebody this set, then probably what he's going to read? He's going to read that this is a set with one element containing 0 as one of the 0 as that element. So this is a set with one element. But when I'm talking about a month which have 32 days, then there is no month with 32 days. So this is not the correct representation. So what is the way out? So how we are going to do? We are going to take the same braces. So this is how you represent any set in a set builder form or in a roster form. And if you list the elements, then it would be in the roster form. If you don't list the element, it would be in the set builder form. But so you can see that I'm just using the braces and nothing is inside it. So such type of set is known as an empty set. It is fundamentally important because many operations, there is a requirement for such set. So this is how you define a empty set. Now we use certain other synonyms like null set, and we use a void set also. So these terms, if it comes, then you should understand that it is a null set or it is a void set. So you can see in the screen that we are using one more symbol for empty set. So what symbol I'm using? I'm using this symbol, somewhat like a 0 and with a cross out. Okay, so if I write, so this is one and the same thing. So this means one. So students should not confuse that whether it is an empty set or not. For example, if I write inside this, but you should be very careful while dealing with empty set. For example, see, if I've written empty set inside with that symbol, but again, this doesn't mean an empty set. Why? Because this is a set with that symbol as one of the elements. So I think this is clear to all the students. So we'll move further and we are going to see more kind of sets. So this was one type of set, and this was a special set that is known as empty set. Okay. Then there is when we define a set, I will give you an example like that. If I suppose I am giving you an example, I want to represent a set, and I'm listing the elements as 1, 2, 3, 4, 5. So this is in roster form. You can write it in the set builder form. You can see that in this particular set, you can count the number of elements. You can count the number of elements. So if I'm going to count with the first element, this is the first element, this is the second element, this is the third element, then the fourth element and the fifth element. So in a way you are able to count the number of elements. So in this particular set there are 5 elements. So in this particular set there are 5 elements. So such type of set in which you can tell, give me a natural number where that natural number represents the number of element of the set, such set is known as a finite set. And the situation arises, suppose I give you another set B, and suppose I write it like this, X, such that X, again, now the symbols are known to the student. X, the symbol belongs to then the natural number N. See, I'm not writing simple N, I'm using a line, then this is just to represent that it is a set of natural numbers, because we generally use bold letter, and while writing we use certain symbols like this. For natural number we use like this, and so for real number somewhat we use like this. So whenever such a symbol comes, you should understand that that is a set. That is not a simple English alphabet. That is a set within, that is representing a set. So I want all those X, I want all those X which belongs to natural number. Probably if you are going to represent this in roster form, so this is the set builder form. If you want to represent this in the roster form, then how you are going to represent this? Probably you are going to start with 1. You're going to start because first 1 is the first natural number. Then you are going to say 2. Then you are going to say 3. Then you are going to say 4. But the problem is that for every natural number, whatever natural number you're going to take, there is a natural number after that. If I'm going to take 4, then is a natural number 5. If I'm going to take 100, then there is a natural number 101. If I'm going to take 1000, then there is a natural number after that, that is 1001. So how to list all the elements in the, if it is on the set builder form, there was no problem, because I just have to state in the form of words, X such that X belongs to natural number. But the problem arises when I have to list them out, because when I'm going to give the set in the roster form, then I have to list each and every element. But this can be rectified in some way. What I'm going to do after 4, what I'm going to do 4, I'm going to use a comma, then I'm going to use 3 dots. I'm going to use 3 dots. Now this 3 dots has a meaning in mathematics. What does this 3 dots means? This 3 dots means that you have to continue. And if I'm not writing anything after the 3 dots, this means that it is going to continue forever. So such type of set where the element continues forever is known as infinite set. So there are 2 sets, finite and infinite set. So in infinite set, when you want to list the element, if you want to use the tabular form, then you have to use these 3 dots to show that this is going to continue. Okay, so I think so it is clear to you. So I want to show certain examples so that you can work. So this is an example which I've done for empty set. So this is find which of the following is an empty set. So this is given in set builder form. X is an even prime number. X belongs to natural number and X is greater than 2. So is there any prime number greater than 2 and which is even as well? There are prime number which is greater than 2. 3 is a prime number. 5 is a prime number. 7 is a prime number. But is there a prime number? But you have to look for an even prime number. So the set is saying that you have to look for an even. So if I write this in set builder form, so this means that this is an empty set. Okay, so this is an empty set. Similarly, you can see that the second example, the set B, it is given in the set builder form. You can see that you have to include all those X whose square is 10. And it is also given that X is an odd number. And X, so there are actually 3 statements. There are 3 statements you have to look for. The first is the square should be 10. And it is given that the X is odd. And it is also given that X belongs to natural number. So you know that if you take any natural number, either it would be an even natural number or it would be an odd natural number. For example, 3 is an odd natural number. But if you are going to make a square of an odd natural number, you are going to get an odd number. But here 10 is an even number. So how many numbers are there whose square is 10? And it should be odd as well. The number should be odd as well. So answer is, again, it is an empty set. It is an empty set. These two examples, generally students get confused that whether it is an empty set or not. As I've discussed earlier, this is not an empty set. This is not an empty set, because this is a set with the symbol with this particular symbol. And likewise, you can see example D also, D set also, it has an element which has 0 as one of the elements. So this is also not a empty set. So in the question what I asked, find which of the following is an empty set. So first and second, these are the example of empty set. The last two, these are not empty set. So for a few more examples for finite and infinite set. X such that, so you have to find whether whether the following set is finite or. So we have discussed about finite set and infinite. So these are the sets which is given in these are the sets which is given in the set builder form. So the first set, A equals to X such that X is a day of a week. So everybody knows that there are 7 days in a week. So you have to list all the. So is it finite or infinite? Because 7 is a number. So I told you, if you can count the elements in the set, then that would be a finite set. So in this case, the number of element is set. And one more thing, the number of element is known as cardinality. Okay, the number of element, there is a special name which is known as cardinality. And how you are going to represent? You are going to represent by this symbol N, then the set A. What does it mean? This means that how many elements are there. So what you have to write? You have to write, this represents the number of elements in the set. So in this particular example, you can see that the number of elements for this particular set is
7.
7, because there are 7
days of the week.
7 days in the week. So this means that so I told you, if you can come out with a finite number, if you can come out with a natural number, no matter how large is that number, no matter how large is the number, that will be a finite set. So this is an example of a finite set. Now the second example, X such that X is a person living on earth. You may feel that there are infinite number of persons who are living in earth, but that is not infinite. That is a large number. That would be a large number. If I asked you, but there would be a number. If you count the number of persons living on the earth, that would be abundant. So this means, again, this is an example of a finite set.
Finite.
So this again is a finite set. Okay. So if you see the third example, Y such that Y is a point on a line. Y is a point on a line. Point on a line. So you know that everybody knows that what is a line. Line is actually this which goes infinite both the ways. Okay, so it goes in infinite. So if I put my anywhere, if I'm going to put, that would be a point. So how many points are there in a line? Can you count? Can you come with a natural number which you can say that yes, this much number of points are there in a line? No, because because line goes infinite, and wherever I'm going to put my pen, that would be a point. So I cannot come with a number. So this means that this is an infinite set. So this set D is also an infinite set. If you come to the fourth example, this again, X says that X belongs to natural number. Again, so this we have discussed that natural number is infinite, because for every natural number there is there is a natural number which is after that. So that we have discussed. So this means that again, so this is an example of an infinite set. So this is an example of an infinite set. But if I see the last example, X says that X is a prime number and X belongs to natural number. So you have to look for the prime number and which is a natural number. So the first prime number, so everybody knows what is a prime number. A prime number is a number which has exactly two factors. So exactly two factors, the number itself and 1. That's why 1 is included. So 1 is not considered as a prime number because one has only one factor. That's why I'm saying exactly two factors. The number itself. So if I say 2, then it has two factors. 2 and 1 itself, 3, then 3 and 1, then 5 and 1. So these are prime number. And the number which are not prime, they are known as composite number. For example, 6. So it has two factors, 2, 3, which is so this means that this is not a prime number. So, but how to see that prime numbers are infinite? How to see the prime numbers are infinite? So this is a bit tricky over here, because if I say that 2, 5, 7. For natural number, I know that for every natural number, there is a number succeeding that. If there is 10, then there is 11. If there is 1000, then there is 1001. So similarly for any, so if you take any natural number, there is a natural number. But that this is not clear that if you take a prime number, if you have a prime number, then there is a prime number. Maybe it happen. It may happen that you start with a prime number, and you keep on counting the prime number one by one, 2, 5, 7, 7, then 11, and at last you come at the last prime number. So in that case, you can say that it's not. So we are going to see it. So in mathematics, certain things we have to prove also. It is not obvious here that prime number is infinite or finite. So we have to prove this. So that's why proof is important in mathematics. Okay, so we will try to prove it. We will try to prove it. We will try to prove that prime is infinite. Okay, so actually you have done in your class 10th, you have done proof. And class 10th, you have proved that root 2 is not a rational number. Okay, so how did you prove it? You prove it by contradiction method. So what is this contradiction method? The contradiction method is that you assume, so what you, contrary to what you want to prove, you assume something and you get some where there's a contradiction. So then you claim that the assumption what I have made is wrong. So I'm going to, so that's because this is important, because mathematics proof in mathematics is fundamental. So let us try to prove it. So how am I going to prove? So we feel that set of prime number is infinite. We feel that set of prime number is infinite. So contrary to our statement, we will assume that the set is, we will assume primes are finite. So we will assume that primes are finite. If primes are finite, because we are assuming, because I want to prove that primes are because we have a feeling that primes are infinite, but contrary to my statement, I'm assuming that primes are infinite. So I'm assuming primes are infinite. If they are infinite, then there would be so if they are finite, then as I told you, you should come with a natural number. That natural number would be a very large number, but there will be a number. So let me tell that suppose there are n prime numbers, P1, P2, P3, P4, and see, I'm going to use these dots now. Again, this dot is used to tell that it will go like this, and the last number is Pn. So we have prime, and they are finite in numbers, P1, P2, P3, P4, and Pn. So contrary to our statement, what do you assume? That the primes are finite, and we assume that there are n prime numbers. Now, how you are going to do? I'm going to construct a new number P now. I'm going to construct a new number P by multiplying all these prime, P1, P2, P3, multiplied by so on up till Pn. Okay, so I multiplied these numbers by, I multiply all these finite number of primes, and what I'm going to do, I'm going to add a 1 over there. I'm going to add a 1 over there. Now, this is what you have learned in your class 10. You have done division algorithm. Okay, so the division algorithm, it is given in the screen, so you can see in the what is division algorithm. If you have two positive integers, then there exists a positive integer q and r, such that a equals to bqr, and where r is the remainder. Okay, for example, if I have 3 and if I have a 7, then what I can do, I can divide this 3 by 7, and I can write this 7 as 3 multiplied by 2 plus 1, and whatever this comes, this is known as remainder. This remainder lies between the number which you are dividing. Okay, so this 3 lies between, this 1 lies between 0 and 3. 0, and it cannot be 3, it is strictly less than 3. So for any two number, there always exists a remainder and there exists a quotient. So this is one thing, and the second is the fundamental theorem of arithmetic which you have learned. Any composite number. So this is another version of which I am using. The actual version is that any composite number, if you have, it can be written as product of 5. For example, 6. This can be written as 2, 3. If you have 100, then you can write as 2 square multiplied by 10 square. So 2 multiplied by 2 multiplied by 10 multiplied by 10. Sorry, 5. 5. So 5. So you can see that every number, every composite number, either the number would be a prime number. So what I would say, either the number would be a prime number or the number is divisible by a prime. So you can see that in this case, 3 divides 6. And so I use the symbol divides. 3 divides 6. So if you have a number, either it would be a prime number or it would be divisible by a number which is a prime number less than that number. Okay. So you, in this particular example, in this expression, you can see that if I'm going to use the division algorithm, so I can write P1 and I can remove the less, P2, P3, and so on up till Pn and 1. So if you see the division algorithm, these are unique numbers. These quotient and remainder are unique. So this means that I'm writing P1. I'm writing P1. I'm writing P as P1 multiplied by, and taking this whole thing, I'm taking it as a whole. So this whole will be representing a number. So this number multiplied by P1. So this means that remainder is 1. So when a number is leaving remainder as a 1, so what does it mean? This means that P1 doesn't divide P. P1 doesn't divide P. Okay, because it is leaving a remainder. Similarly, you can show that P2 doesn't divide P. And so on up till Pn doesn't divide P. So what you are seeing, that number which you have constructed, the number P which you have constructed is a number which is not divisible by any of the prime number, which is not divisible by any of the prime, which we are assuming that these are prime. And you know that a number, either it would be a prime number or it would be a number which is divisible by a number which is less than number. This number is less. You can see that this number P is greater than each of these Pi's. P is greater than P1, P is greater than P2, and so on. P is greater than Pn. Okay, so P is greater than P1, P1, P. So this is a number which is greater than each of the prime, which you are assuming that these are the only prime. But according to a fundamental theorem of arithmetic, it states that either a number would be a prime or it would be divisible by a prime. Now it is not divisible by a prime. So what does it mean? It is a prime. So this means that P is a prime. P is a prime. So what you got? You started with finite number of primes. You told that there are n primes, and you are claiming that there is, and this is giving us a contradiction because this P is not in this set. This P is not in this set. This is greater than this. This P is greater than each of these Pi's. So you got a prime which is greater than Pi. So this is a contradiction. So our assumption is wrong. So what was my assumption? My assumption was that there are finite number of primes. So mathematics proof is important, because if I ask you in general that what is prime finite or infinite, you cannot come, but you have to. So there is a way to do that. So this is one of the way where we can prove that there are infinite number of prime.
Dr. Thomas, we have a
Yes.
few questions from the students if we can take up at the
Yes,
end of the
yes, ma'am.
session.
Yes, ma'am. Please.
First question, sir, you were also mentioning set builder form. I heard you saying. So
Yes.
one of our viewer is asking to please discuss an example for converting set from roster to set builder form.
Roster to set builder form.
Yeah.
See, I have discussed. So suppose let us take one example. Roster.
Yeah, a very small example. Maybe there is some confusion.
Okay,
with the viewer.
I'll take one example. Roster to set builder form. So suppose I have a set A equals to 2, 4, 6, 8, 10. Okay, so I'm taking a finite set. Now the students know what is a finite set and what is an infinite set. So this is an example of a finite set. Is this in roster or a set builder form? This is in roster form. So student wants to know how to convert from roster to set builder form. Set builder. So this is in roster form. So this is in set roster form. So I'm going to convert this into set builder form. So how we are going to convert this? I'm going to give the same, because I'm going to convert the same set. So I will give the same name A to that. After that, we have to use equals to sign. Then we have to start with this braces, and we have to use a symbol. As I told, this symbols means for all elements. So for all x. So how it is read as for all x. So this set A contains an element which contains certain properties. So I have to, and after that there is a symbol which is known as such that. So for all x such that. Now we have to list the property. Now you can see what is the property of this set. What is the property of this set? You can see that these are even numbers. Starting with, because 2 is the first even number. If I see natural number, so 2 is an even number. Then it is 4, 6, 8, and 100. So how I can write even? Either I can write in words that x is an even number. So this is one way, and the other way is that I can write x equals to 2n, because every even number will be multiple of 2. So these are the numbers which is a multiple of 2. So this is a statement. Actually, this is a mathematical statement I'm writing. X equals to 2, and this is a mathematical statement. So I have to take all the, but you can see in the set, all the even numbers are not coming. 12 is also an even number, but this doesn't belong to the set. 12 is also an even number, but it doesn't belong to the set. So we have to look for those numbers which belongs to set. So what we have to do? So what I can do, now I have to tell from where my n is ranged. So you have to write the list of statements. So this is the first statement. Then I have to write more statements now to describe the set fully. So how I'm going to write? I'm going to write our n goes from 1 to 5, because the first number is 2 multiplied by 1, that would be 2. The second number would be 2 multiplied by 2, that would be 4. So you can see, but now also it is not complete. Why it is not complete? Because if I'm right, n is from 1 to 1, so there exists number like 1.5 also. Because 1.5, but we don't want that number. So we have to, critically we have to tell from where this n is coming. So from where this n is coming, this n should come from natural number. So this completes. So this is how you convert any set which is in roster form to a set in set builder form. So this format should be understood, that there should be a variable, and after that you have to use a colon, and you have to describe that variable. What is the property of that variable? So this is how you convert for tabular form to set builder form.
Yes, sir. Dr. Thomas, another question asked that can we apply concept of prime or composite on negative integers? If you can give some reasons for that.
See, generally speaking, when we define prime, we define for the positive numbers. But prime is defined for negative integers also. Okay. Likewise, we are defining negative positive prime. We can define negative prime also. But you should understand that 1 is not a prime. 1 is not a prime. So because it doesn't come in the definition of prime. Because it doesn't have two factors. A prime should have exactly 2 factors. 2. 2 has 2 factors, 2 and 1. 3 has 2 factors, 3 and 1. But as far as class 11th is concerned, you have to concern with numbers which are positive prime numbers. Any more question, madam?
No, these are all for us for this session. If we are left with 4 minutes only, if you can sum up the session for the students. And if you want to introduce any new concept in a fast way, you can do that.
Okay. So these are some questions for our students. So again, if the students wants, you may take the screenshot so that you can work on it. So
they can practice with these examples.
Yes. So I just want to summarize what I've done now, because we are not left with time. So I just want to summarize. As I started with, set is an important concept in mathematics, because if you see other concepts, because mathematics has a peculiar nature. Mathematics has a peculiar nature that it is interconnected. So if you don't know one thing, you may find it hard to, if you don't know set, then you may find to define what is relations, what is function, because they are defined on the set. So it is very fundamental, and a student of mathematics should know what is a set and how to represent a set. So today what we have done, we have seen different types of set. We have seen what is an empty set, what is a finite set, what is infinite set. Likewise, there are more things which will be coming, which would be dealing in the coming sessions we would be dealing with. So it is necessary that the students should understand it. I just want to take this chapter which is in set. For the student, my advice is that to take it seriously. There are many misconceptions, as I have told, that if I include 0 within a set, then that is not an empty set. So that concept should be understood. And then what we have discussed about why proof is important. Because just by seeing, and he said we cannot claim that it is finite or infinite. Or you're just making a statement. We cannot say that it is like in class 10 the student has studied root 2 is not a rational number. So they have proved this. That's why proof is important. So proof is another aspect which is important in mathematics, and the students should cultivate the habit of proving things, because apart from mathematics, they're not going to find proof anywhere. If you go for chemistry, if you go for physics, you do verification over there. But proof is something which is in the arena of mathematics only. So that is something that is something which the student has to practice, because in the subsequent classes they have to do more things like this. Madam.
Thank you so much, sir, for joining us for this session, and some of the topics which are left in this chapter sets, we will be taking up in our next session. Thank you so much, Dr. Thomas, for joining us.
Thank you, madam. Thank you.
That's all for this session, but do remember, sir has given you examples to solve. There are certain questions that have been given. If you solve them, you can come back to us with your answers and we can share it with Dr. Thomas as well. He can suggest if you have done it right or wrong in the next session. So you can mail us at ciet.kishoremanch@gmail.com. Okay, your answers, and you can do practice as well. We will keep coming to you with more such sessions. That's all for this session, and after a couple of minutes, we'll be back with the Hindi session. And this time, this will be for class 12. So stay tuned. Namaskar.